Okay, I'm going to start section 1.3. We're going to spend some time in 1.3, and 1.3 is going to be the last section that we'll do in chapter 1, by the way. 1.3 is just like a general problem-solving section. We got a bunch of problems here, and the idea is for us to look for ideas for problem solving, okay, and use one of the ideas that are listed here. So the first one, make a table or a chart. Second one, draw a picture. Look for a pattern. Use inductive reasoning. Okay, the first two sections, 1.1 and 1.2, were all about inductive reasoning. Okay, and so sometimes we need to use that when we solve a problem. Sometimes it's helpful to solve an easier problem. Okay, and sometimes it's helpful to work backwards. Sometimes you gotta guess and check. Sometimes it's going to be good for us to form an equation and solve it, or use a formula if it applies, or look for a catch. Okay, if an answer seems too obvious or impossible, look for some sort of catch in the problem. So, problem 23, it says, if the following pattern continues, what letter will be in the 243rd position? Okay, you got hip, hip, hooray, hip, hip, hooray, hip, hip, hooray, hip, hip, hooray. Okay, now the idea here is to count the letters, and of course I don't need to count up to 243, that would be very time consuming. But if you count one time where it says hip, hip, hooray, there should be 12 letters. Okay, so hip, hip, hooray consists of 24 letters. If I have hip, hip, hooray, that's 24 letters, and then if I write that 10 times, 24 times 10 would be 240. So an H would be the 241st letter, an I would be the 242nd letter, and a P would be the 243rd letter. So P would be the right answer, okay? And in that problem, you're using inductive reasoning. Now, obviously, I didn't write this out, 24 times, although I could. Okay, but the idea is to observe the pattern and from the pattern make a prediction. Problem 24. Bacteria in a petri dish double the area that they cover every day. If the dish is covered after 16 days, on what day was only a quarter of it covered? Okay, in this problem you're going to have to work backwards. So the dish is completely covered on 16 days, which means on 15 days it's going to be half covered. And on 14 days it's going to be a fourth of it covered, or a quarter of it covered. Okay, so, oops, sorry about that. So the answer here would be 14 days. Okay. Problem 25. Some children are standing in a circle. They are evenly spaced and marked in numerical order. The fourth child is standing directly opposite the 12th child. How many children were there in this circle? Okay, so sometimes it's helpful to draw a picture, and from the picture you can get the answer. Okay, so the fourth child is opposite the 12th child, which means that the fifth child would be opposite the 13th child, the sixth child would be opposite the 14th child, the seventh child would be opposite the 15th child, the eighth child would be opposite the 16th child. Now, I don't want to keep going here, but the third child would be opposite the 11th child, the second child would be opposite the 10th child, and the first child would be opposite the 9th child. Okay, so I've enclosed the circle. The 8th child is opposite the 16th child. So it looks like there's 16 children that are standing in this circle. Okay, so 16 would be the answer. Problem 26, you have the misfortune of owning an unreliable clock. The one you have loses exactly 24 minutes every hour. It is now showing 3 a.m., and you know that it was correct at midnight when you set it. If the clock stopped an hour ago, what is the correct time now? Okay, so for this one, I'm going to make a chart. I'll keep track of the correct time and the incorrect time. Okay, so We know that it was correct at midnight when we said it. So after 1 hour, now each hour is going to lose 24 minutes. Okay, so after the first hour, it just lost 24 minutes. So the time that it's going to show when it's actually 1 a.m. is 12:36 a.m. Okay, another hour is going to go by and it just lost 24 minutes. Okay, so it's gaining 36 minutes if it's losing 24 minutes. 12:36 plus 36 gives you 1:12. Okay, another hour goes by. It's going to gain 24 minutes, or 36 minutes, excuse me. So it was just 1:12, so it's going to be 1:48 a.m. Another hour goes by. It's going to gain 36 minutes, so it's going to show 2:24 a.m. Okay, another hour goes by. It's going to gain 36 minutes, so it's going to show 3 a.m. And then it just stopped. Okay, this is a very unreliable clock. If the clock stopped an hour ago, okay, so it was 5 a.m., so 6 a.m. would be 1 hour. 6 a.m. would be the correct time that the clock should show. Okay. So for that one, we need to make a chart. Problem 27. In a spelling competition, all the competitors were on stage together. After 3 minutes, a fifth of the students had made mistakes and were excluded from the competition. In the next 5 minutes, half of those remaining were eliminated by extremely difficult words. 2 minutes later, 4 students were found cheating and were sent home. After 15 minutes of the competition, half of the remaining students had made mistakes and left the stage. In the last few minutes, one more competitor made an unfortunate mistake and one contestant was left in the winner of the spelling competition. How many children originally entered the competition? Okay, so the idea here is you need to work backwards. Okay, so if I read this backwards here, last few minutes, one more competitor made an unfortunate mistake. Okay, so the one person had to beat the other person, so there's 2 people left. Okay, after 15 minutes, half of the competition made mistakes, left the stage. Okay, so half of 4 would be 2. 2 minutes later, 4 students were found cheating and were sent home. Okay, so that would mean I'd have to add 4 to 4, which gives me 8. In the next 5 minutes, half of those remaining were eliminated by extremely difficult words. Okay, so half of 16 would give me 8. Okay, so at that point there was 16 students remaining. After 3 minutes, a fifth of the students had made mistakes and were excluded from the competition. So a fifth left, which means that 4/5 remained. Okay, so 4/5 times a number would give you 16. Okay, or the number would be equal to 5/4 times 16. Okay, so 16 times 5 would give you 80, and 80 divided by 4 would give you 20. Okay, so there were 20 students on stage when the competition began. Problem 28. Cindy was asked by her teacher to subtract 3 from a certain number and divide the result by 9. Instead, she subtracted 9 and divided the result by 3, giving an answer of 43. What would her answer have been if she had worked through the problem correctly? Okay, so let's see here. Cindy was asked by her teacher to subtract 3 from a number and divide the result by 9. Okay, so that's what she needs to do. She did not do that, though. Instead, she subtracted 9 and then divided by 3, giving 43 as the answer. Okay, so what is the original number if she would have done this correctly? Well, 3 times 43 would give you, what? If we take 3 times 43, we get 129, okay? Plus 9 gives us 138. Okay, so the original number there was 138. If she had worked through the problem correctly, okay, subtract 3 and then divide by 9, 138 minus 3 gives you 135. And 135 divided by 9 should be 15. Okay, so 15 is going to be the right answer. Okay. Let's try problem 29, where it says that a drawer contains 20 black socks and 20 white socks. If the light is off and you reach into the drawer to get your socks, what is the minimum number of socks that you must pull in order to be sure that you have a matching pair? Okay, now the drawer only has black and white socks. I see so many times where, you know, a student will say, oh, the answer is 21. Well, no. So that would mean that you'd have several pairs of socks. Okay, we just need one pair. And by the way, a key word here is minimum. What is the minimum number of socks that you must pull out in order to be sure that you have a matching pair? Well, 3 would be the answer. With 2 socks, you could have one of each color. So you could have a black sock and a white sock. What's going to happen if you pull the next sock out? It's going to be black or white, therefore giving you a match. Okay, so 3 socks would be the minimum number that you could pull to be guaranteed to have a match. Problem 30, a prime number is a number that is evenly divisible by 1 in itself. If we were to list all the prime numbers in order, the 304th number would be 2003, and the 306th number would be 2017. What is the 305th prime number? Okay, so you want to use guessing and checking here as the strategy. We're going 2004 to 2016. Okay, so I've listed all the years between 2004 and 2016. Now, any year that is even, I can immediately cross off the list. Since 2 is going to be the only even prime number. A prime number is one that is evenly divisible by 1 in itself. Okay, because any other prime number is going to be divisible by 2. So 2 is the only even prime number. So 2004 is gone, 2006 is gone, 2008 is gone, 2010 is gone, 2012 is gone, 2014 is gone, 2016 is gone. Anything that's a multiple of 5, you can cross off the list since 5 would go into that number evenly. 2005 is gone. 2010, we've already crossed that out because that's an even number. 2015 is gone. Okay. Now, for the ones that remain, which is 2007, 2009, 2011, 2013, we'd basically kind of go through the list here. If you were to check, 3 divides 2007 and 2013, or 2010, 2013, 2016, 2019, okay? And if I just check this, 2007 divided by 3, okay, it divides that evenly. Of course, any multiple of 3 would go into that evenly. Okay, so 3 is going to divide 2007 and 2013. Cross those off. If you were to play around with the numbers there, 7 goes into 2009. Okay, if I check that, 2009 divided by 7 is evenly divisible, but it's 287 would be the correct number. Okay, so 2011 would be the answer. 2011 would be the 305th prime number, okay? And that would be the answer there. Okay, Why don't we go ahead and stop right there?